and welcome to the NEST Climate Systems Hub webinar, Exploring the Edges, what our research is revealing about uncharted climate futures. So my name is Heidi Evans, and I'm a knowledge broker with the Climate Systems Hub. And as the New South Wales knowledge broker, my role sits in the New South Wales Department of Climate Change, Energy, the Environment and Water. So that's the New South Wales TQ, not the federal one. So today we're going to delve a little bit deeper into the unknown, those plausible climate futures that conventional projections maybe aren't capturing or that haven't been fully explored yet. So we've got three speakers from the Climate Systems Hub project, Uncharted Climate Futures, who are going to share some of this really fascinating and important work with you. But before we begin, I'd like to acknowledge the Wongal people of the Eora Nation, who are the traditional custodians of the lands in Sydney here, where I'm joining you from today. I want to pay my respects to their elders, past and present, and I want to extend that respect to all First Nations people joining us today. The Climate Systems Hub recognises the important role traditional knowledge plays in understanding our climate. And we know you're dialing in from across Australia, maybe even internationally. Please take a moment to think about the traditional owners of the lands where you are joining from. Okay, so a few housekeeping notes before I introduce our first speaker. This webinar is being recorded. The link will be made available on the NEST Climate Systems Hub webinar in the coming days. We really encourage you to ask questions, and you can do that at any time. You'll see the Q&A function at the top of your screen. So use that Q&A function to pop your questions in there. And also note that if someone else has popped a question in there that you really want answered, you can vote for that, which will bump it up the list. We'll try to get to as many of those as possible after our speakers have presented. However, we might not have time to get to them all, so get in early. And if this is your first Climate Systems Hub webinar, a big welcome to you. The webinars are designed to provide an opportunity for learning and interaction with a broad range of topics and experts. We've got some great presentations lined up for the rest of the year, and we'll let you know at the end how to make sure you don't miss out on any of them. Okay, so that's definitely enough from me. Without any further delay, I'd like to introduce our first speaker, Sagat Nasi. So Sagat is a senior research scientist at the Australian Bureau of Meteorology and leads the Climate Systems Hub's Uncharted Climate Futures project. So his research focuses on improving and delivering climate change projections for Australia with a particular focus on rainfall. So I'm going to hand over now to Sagat. He's going to tell us a bit more about the project and how the research we're discussing today connects with that broader uncharted climate futures context. So over to you, Sagat.
Great, thanks, Heidi. Thank you all for joining us today and for the opportunity to speak about this project. And I just want to note that the speakers here today, we're representing a group of more than 20 scientists and knowledge brokers. So I hope we do their work justice. This is a very broad group that we organize under what I believe is a very important project theme. We're calling it Uncharted Climate Futures. And I'd particularly like to acknowledge Michael Gross from the CSIRO and Australian Climate Service, with whom I'd originally conceptualized this project idea and what's turned into a really nice group of people. Okay, next slide, please, Heidi. Great, so we're in a position now, and I'm just going to introduce this topic, by the way, and we're going to have a couple of other speakers who are going to give us a bit more detail. So just a bit of background first. And I guess the kind of really important point to note here is that in Australia, we're really fortunate to now have access to high quality, high resolution regional climate change projections, and those are offered by multiple climate services, either at the state or federal level. And these projections are reliable and should be central to your future planning. Now that these kind of high quality, high resolution climate change projections are available, we can start to consider other questions. And today we'll discuss this key concern, which is, are conventional projections offered by climate services missing some important regional climate change scenarios? And to ruin the surprise, let me tell you that we think the answer is yes. These two images on the screen now, they show projections from many state-of-the-art global and regional models. And though it may be hard to accept because there's so much future climate data in terms of models, scenarios, analysis methods that are currently on offer, we may still be missing something quite important. So we're calling them uncharted climate futures. It's a nod to prior work that described climate futures for Australia. Next slide, please, Heidi. So what do these uncharted futures look like? In this project, we focus on problems in three broad categories, and we're going to focus on two of them today, but I'll first describe what these three categories are. So there are emissions pathways that are currently not well explored by climate services, so you'd be familiar with the high, medium, and low type scenarios. Andrew is going to speak to us today. Andrew King's going to speak to us today about overshoot and long-term stabilization pathways, and those are emission scenarios where you overshoot a global warming level or global warming target, come back down, and then stabilize over the long term. What do those mean for Australia? There are also global model responses that are plausible but are not well represented in conventional projections or conventional climate change models. And so today we've got Andrea Teschetto speaking to us about a missing model response in the tropical Pacific, which may turn out to be very important for Australia. And also there are regional variability futures which may not be present in conventional projections, and that's either because of model biases or undersampling of rare events. That's a topic that's not covered in detail today. But I just want to stress to you that there is more, there's much more that we don't investigate here, and that includes things like tipping elements, geoengineering scenarios, and compound events. We can't do it all, but hopefully we're opening an important conversation in regional climate change for Australia that will help us to make better decisions in the future and inform our future planning with the best possible evidence. And with that, I'll hand back over to Heidi to introduce our next speaker. Thanks.
Fantastic. Thanks, Sagat. That was some really great scene setting for the remaining presentations. So everyone else, make sure you keep those questions coming in the Q&A function. But for now, let's move on to our next speaker and we'll get to those questions at the end. So I'd like to warmly welcome Andrea Teschetto. Andrea is an associate professor at the Climate Change Research Centre at the University of New South Wales and chief investigator in the ARC Centres of Excellence for Climate Extremes and the 21st Century Weather. So over to you, Andrea.
Thanks so much, Heidi. Thanks for having me here today. It's a pleasure to be here. So today I'll be talking about our project on understanding Australian climate change under Pacific projections. So this work is being done by a number of people. I list those people at the bottom of this slide. So Christine Chung, Huajin Lee, Ghislaine Beauchamp, and Zoe Gillett, Abik Centra, Shane McGregor, and Sugata Nasi. They are all involved in this project. So what I'm going to talk here today is I will give a brief overview of the Pacific Ocean. I'll talk about the global impacts and how it can impact Australian climate. I'll show that I'll talk about how the tropical Pacific is changing in observations and what the climate models simulate and what the climate models project for the future. And we'll discuss why do we care about those projections and what we are trying to do in NESP under the Uncharted Climate Futures project. So let's get started. So the Pacific Ocean covers 30% of the global oceans, and it's home to the largest climate phenomenon that we know as the El Niño Southern Oscillation, or ENSO. On the right-hand side, I show an example of an El Niño event. This occurred in 2015-16 on the top, where you can see this warming spreading across the equatorial Pacific and reaching the coast of South America. And on the bottom right is an example of a La Niña event that shows cooler water in the equatorial Pacific. And this event was quite a weak event that happened in 2017. So El Niño causes significant changes in global mean temperatures. A lot of the warming associated with strong El Niño events propagates through the tropics and causes the ocean basins to warm as well, the other ocean basins. The consequence of this is a temporary increase in the global mean temperatures when strong El Niño occurs. So El Niño and La Niña also leads to changes not only in temperatures, but circulation and precipitation, and not only in the tropical Pacific, but also in other regions in the extratropics, as is illustrated here on the left-hand side. So you can see that is associated, El Niño is associated with dry conditions in South Africa and wet conditions to the south of the US, for example. The impacts of the El Niño Southern Oscillation depends on the region and season we are looking at. For Australia, up to 40% of precipitation variability from September to November can be explained by a combination of climate phenomena, including ENSO, but also to what happens in the Indian Ocean and the Southern Oceans. ENSO is by far the most important climate mode for Australia during that time of the year. On the top right figure, I show it's an analysis that was done by Sana Hobeck in 2024, and it shows the importance of a region in the equatorial Pacific that is close to Australia. This region is named Niño 4 region, and it shows the importance of this region for precipitation between September and November. And in this study, she used the machine learning techniques to try to identify how much precipitation could be attributed to modes of variability. And what she finds is that ENSO has a very high importance for Australia during spring season. On the bottom, we can see these two panels from the Bureau of Meteorology, and it shows that on average, El Niño increases the chance for dry weather in the eastern half of Australia, so in these red regions, while La Niña typically increases the chance for more rain over most of Australia. Okay, so how is the Pacific Ocean changing, and what do climate models tell us about the future? As we know, the world is warming with the increase in greenhouse gases, but this warming is not uniform. So some areas warm faster than others. The land warm faster than the ocean, and the oceans warm faster in certain regions. For example, here this global map shows that the northern hemisphere is warming faster than the southern hemisphere, and also Atlantic and Indian Oceans. When we look at changes in observations in the past few decades, from 1980s to the present, what we see is that the tropical Pacific has cooled close to South America, while the water close to Australia has warmed since 1980s. And this happens together with a strengthening of the winds that blows from South America to Australia, because this is a coupled phenomenon. And since this cooling pattern looks like a La Nina, it has been referred in the literature as a La Nina-like pattern. But here when I talk about La Nina-like pattern, please keep in mind that I'm talking about the changes in the mean states in the Pacific, so long-term changes. When we look what the climate models simulate for the same period, from 1980s to 2014, what we see is that the models agree that the world is warming, but they do not agree on where this warming happens and how fast it happens. So there is no cooling in the Eastern Pacific, and instead what we see is more of a uniform warming pattern. Now, if we look at what climate models project in a warming future, we see a higher warming everywhere, and in the Pacific, climate models project more of a warming in the Eastern Pacific than Western Pacific, close to Australia. And because this pattern looks like an El Niño pattern, then some literature, some studies have referred to it as an El Niño-like pattern. Okay, so another way to show this is through this visualization that was produced by the Access NRI. On the left-hand side, we see how observations have changed since the 1900s to 2014. And I'm going to play this animation now. And we can also see what the model simulates for the same period. You can see from this animation that the Pacific undergoes natural variations from decade to decade, with some decades warming more than others. And that is what makes it difficult, to separate, it's really difficult to separate these temporary shifts, decades from decades, that are natural from our climate system, from the permanent climate change that is driven by increased greenhouse gases. So I'm going to play that again. Climate models do not simulate as much decadal variations, it's less intense, and they instead tends to just warm kind of more uniformly than what observation is showing. So the question is why there is this mismatch between climate models and observations. So that's what scientists are trying to answer. The fact that climate models do not simulate a warming that is similar to observation suggests that critical processes might be missing or might not be correctly represented in those models. And this is a really hard question to answer, I must say, because the tropical Pacific mean state response to global warming is a result of multiple competing processes, like including air-sea interactions and feedbacks, cloud radiative processes, ocean adjustment mechanisms, internal variability, a lot of other processes here. I'm not talking about, I won't be talking about those processes here. And as we go to a warmer climate in the future with the increasing greenhouse gases, then climate models they generate a stronger warming along the equatorial Pacific that is closer to South America. So I'll just play that now again, the projections to the future. You can see that the warming is stronger closer to South America. Okay, so the current assumption based on climate models is that the Pacific mean state will warm faster in the east. But observations suggest a possibility of a future scenario that looks like a La Nina pattern, where the waters close to Australia warm faster than near South America. And this scenario is not accounted for in climate models, which implies that our regional projections could be incomplete. We actually don't know what is going to happen in the future because, we don't have a crystal ball, but because there are uncertainties too, like there are uncertainties on like observations, and if we go past past observations have certain limitations, natural variabilities, and model biases. And on top of all that, climate change scenarios are based on certain assumptions about how our world will change in the future, how much emissions we'll have, population growth, and so on. So based on multiple possible scenarios, we can consider these two scenarios as the most probable based on climate models and observations. So a La Nina-like scenario where the observed temperature difference continue to strengthen, warming more the Western Pacific closer to Australia than the Eastern Pacific. And another scenario that is an El Nino-like scenario where the temperature difference between East and West weakens, leading to a warmer water close to South America. Why do we care about that? Well, the tropical Pacific modulates the pace of global warming via air-sea heat exchange and the uptake of carbon from the atmosphere. I also showed before that the Pacific influences rainfall weather systems around the globe. And the Pacific influences Australian rainfall via changes in the El Niño Southern Oscillation. And how ENSO will change in the future also depends on how the Pacific mean state will change. If the tropical Pacific mean state evolves differently than we project, it could lead to unexpected impacts in regional climate patterns and rainfall variability, with perhaps some unforeseen consequences for agriculture, water resources, and ecosystems. So these two scenarios have different implications. And I'm putting here in this table just some examples. Please do not interpret them as predictions for the future. This is not the idea. These are examples of maybe some of the things that can be different in those two scenarios based on what we know from previous studies. So an El Nino-like scenario, for example, could speed up global warming because the oceans would absorb less heat, causing air temperatures to rise faster. A La Nina-like scenario, on the other hand, would temporarily slow the global surface warming rate by absorbing more heat into deep ocean. The rainfall patterns could be different in these two scenarios, with an El Nino-like feature perhaps causing a little bit drier climate for us, while a La Nina-like feature could potentially intensify rainfall patterns, causing maybe a stronger wet seasons and worsening drying conditions everywhere elsewhere. Extreme weather events can be different as well. So an El Nino-like mean state could perhaps bring more frequent droughts in certain regions, while a La Nina-like mean state might intensify storms and tropical cyclones for Australia. And the impacts on marine life and ecosystem, then could be very strong as well. So with an El Nino-like mean state, that could bring more warmer and less nutrient waters to the surface and threaten coral reefs through persistent heat stress, and a La Nina-like mean state, increasing the risk of marine heat waves in other regions, for example, off the west coast of Australia. And on top of all of this, we know that the relationship between year-to-year variability, so ENSO and Australian rainfall, is linked to the Pacific mean state. For example, the influence of El Nino and La Nina on Australian rainfall is amplified when we have decades with cooler conditions in the tropical Pacific, for example, via the interdecadal Pacific Oscillation. All right. So given the global implications from those two future scenarios, we need more targeted research to clarify how the Pacific will change. And this can help stakeholders and policymakers to better prepare for both scenarios and their impacts on weather, agriculture, water resources, ecosystems. So what we are doing in NESP, in NESP, we are trying to understand, doing research to try to understand projected changes in a warming climate with a focus on the uncharted Pacific La Nina-like scenario. This is one of the major climate questions that top scientists around the world are trying to answer, but nobody is really looking into what it means for Australian climate, and that's where NESP comes in. So our project are trying to look at this problem from different aspects, and we are assessing future scenarios that are not well captured by the current climate models with a focus on the tropical Pacific. We are looking at the impacts of those scenarios on Australian climate. We are trying to understand why there is this mismatch between current modeled and observed trends. And by doing that, we are designing and running idealized experiments using the access model to try to understand the processes that leads to this La Nina-like scenario and looking at the impacts basically for us. So I'll stop here. I'll ask you all to keep an eye on what comes in NESP next. I think next month we'll have an explainer on that, so you can have more details about our project. Thank you.
Thanks, Andrea. Thanks for sharing. It seems to be a real challenge that the Pacific warming observational trends just don't seem to line up with the projections. So definitely something worth exploring. Okay, there's some really good questions in there. Thanks everyone for intensely listening and popping those in. So we'll get to those at the end. I'm going to introduce now our third speaker, Andrew King. So Andrew is an associate professor in climate science at the School of Geography, Earth and Atmospheric Sciences at the University of Melbourne, and a chief investigator in the ARC Centre of Excellence for the Weather of the 21st Century. Andrew is interested in climate change projections under the Paris Agreement and net zero emissions pathways, understanding the effect of the rate of global warming on regional climates and seasonal prediction of climate extremes. Over to you, Andrew.
Thanks, Heidi. So today I'm going to talk about how we what happens to the climate if we achieve our policy goals and actually reach net zero emissions? What comes next? What happens if we delay getting to net zero as well? So these are really important questions that until relatively recently haven't been a major focus in climate science. So just laying some groundwork, as you know, we all already know, we've got very high greenhouse gas emissions and we're warming the planet very quickly. And we have a near linear relationship between our total cumulative carbon dioxide emissions and overall global warming. So we're used to thinking about this. We're used to thinking about a continually warming world. And this very strong relationship has helped to motivate the need to achieve net zero emissions. Really, net zero emissions is about not moving further right on this diagram, this IPCC graph, halting the increase in our cumulative CO2 emissions, with the goal then to halt further global warming beyond that point. Net zero emissions means that there would be a balance between our human-caused greenhouse gas emissions and our removal of greenhouse gases from the atmosphere. This could be achieved this will be achieved through a combination of decreasing emissions and increasing carbon uptake. Australia has a net zero target for 2050, along with lots of other countries. And really, the expectation is that if we can achieve global net zero, so globally, our emissions, humanity's emissions are balanced by our uptake of carbon from the atmosphere, then we should halt further global warming. In reality, if we get to that point, we would likely already have the momentum to kind of keep going, to increase our uptake of carbon and to continually reduce our emissions. So if we can get to that point, it's likely we would actually go a bit further and achieve net negative emissions, where we're pulling more carbon out of the atmosphere than we're putting into it. And if we can achieve net negative emissions, then we'd likely we should be cooling the planet back down, especially if it's a substantial level of net negative emissions. And this is something that we're on track to need to do, really. We've already had our first year above 1.5 degrees relative to pre-industrial levels, and it's looking, basically certain that we're going to go through 1.5 degrees, and we're really on track even for more than 2 degrees of global warming. So in order to achieve our Paris Agreement commitments, we're looking at a reliance on future net negative emissions. And this would mean overshooting those targets temporarily. So that's something that's becoming more discussed in policy-making circles, as it's something where it looks like we're almost committed. We're on a path that commits us to doing this almost. So we really need to understand what net zero and overshoot futures look like. And I think it's worth noting here that often when I talk about net zero and overshoot, I think people think this is almost like science fiction. We've got very high greenhouse gas emissions. We're quite far from these points. But we are going to get to net zero at some point. We have to halt. We can't just have continual global warming forever. And we need to understand the implications of getting to net zero sooner or later and achieving net negative emissions on different scales sooner or later. So there's lots of questions we really need to understand. How the climate will evolve under net zero and overshoot. Can we reverse changes in the climate system that we're seeing at the moment? The effects of delay in reaching net zero and how climate risk might evolve in a post-net zero world. As Sugat was kind of already hinting at, this has not really been the focus of most climate science to date. We're really used to thinking about 21st century projections where we have continued greenhouse gas emissions. And even though we have some scenarios, this is a graph showing those scenarios that we're used to thinking about from CMIP 6. Even though we have some scenarios that go to net zero and net negative late in the 21st century, they don't really, that's not really enough information there to actually understand the implications of net zero and net negative emissions, especially on longer timescales, where further changes are likely to emerge. So we need to understand a post-net zero future. And in the hub, we're working to address those questions that I was talking about before. And we have a specific focus on Australia. So we're using some multi-model simulations that include other modeling centers around the world, as well as the Australian Earth system model. But we've also run a bespoke set of 1,000-year-long net zero emission simulations with Access, the Australian Earth system model, to try and better understand net zero and overshoot futures as well, and particularly what Australia's climate might look like in these futures. So I'm just going to talk about a very small sample of our results today, but we're doing lots of work on this topic in general. I'm just going to show a few results based on the Access, the Australian Earth system model, 1,000-year-long net zero simulations. So the first thing to note is that we've run simulations where we turn off emissions at different points in the 21st century and just let the climate evolve for 1,000 years. And we've done this at 5-year intervals in the 21st century, starting in 2030. The bottom left graph here shows the CO2 concentrations in the atmosphere under these net zero emissions simulations. Yellow to red is just these different simulations starting net zero earlier or later. And we can see that after net zero, we expect CO2 concentrations to decline in the atmosphere, but global warming, while it will slow down, would continue based on these simulations. So the bottom right graph shows the global average temperature anomaly relative to early industrial levels in these 7 1,000-year-long net zero simulations. And you can see this kind of slow warming in these simulations over 1,000 years. But one thing to note is a delay in achieving net zero emissions and then maintaining net zero, that the effect of that carries through for many centuries. And we still have a difference in our simulations if we delay achieving net zero in the 21st century. Obviously, we're not just interested in global average temperature. We're interested in what Australia will experience, what other parts of the world will experience. I'm just showing some temperature results here, but we've looked at other climate variables as well. The maps on the left here show the long-term changes in temperature under net zero emissions within these different simulations, just for net zero starting in 2030, 2045, and 2060. So this is just the change after net zero is achieved in those simulations. And what we see is that even though the global temperature is slowly rising in these simulations, kind of at a similar rate between them, the pattern of temperature change is quite different. And if we delay achieving net zero, it looks like we'd have more of an interhemispheric difference in future temperature change, with cooling more likely in the north and warming more likely in the south. If we delay achieving net zero, we'd have greater post-net zero warming in Australia. We can also look at what this means for where people live. And these histograms I'm now showing show the proportion of population experiencing different local temperature changes in these 3 different simulations. Again, post-net zero. So this is all after net zero has started, but on the top, it's where net zero is delayed relative to on the bottom. The yellow histograms show the global population, the distribution of temperature changes in those locations, and the red is just for Australia and New Zealand. And what we can see is Australia and New Zealand are outliers, and that's expected based on the maps on the left. We will experience a different change post net zero than other parts of the world will. And we need to be prepared for that. And we can't really rely on the work being done in other parts of the world to understand post net zero climates, because they won't be so focused on our parts of the world, on Australia. So really, that's just for temperature changes, of course, but we know that many other aspects of the climate would continue to evolve under net zero and overshoot scenarios. So post peak global temperatures, or post the achievement of net zero emissions, we still expect to see continued sea level rise, continued warming of the Southern Ocean at the surface and at depth, and continued decline of Antarctic sea ice. Whereas in the Northern Hemisphere, there'll be more quick reversal of climate changes, including for Arctic sea ice. So even under net zero and overshoot scenarios, we expect some aspects of the climate system to continue shifting away from pre-industrial states. And we need to think about our evolving climate risks and what we might expect to see in a post-net zero world. We're used to seeing, we're used to thinking about changes in a warming world, and this includes more frequent heat waves on land and in the ocean, increasing sea level, all these other changes. Post-net zero, we'd expect quite different changes. So maybe a reduction in Northern Hemisphere land-based heat waves, but possibly not for us in Australia. But some other changes that we see in a warming world would continue post-net zero. So we need to really understand this. This is, at the moment, this is very kind of broad brush conclusions about changes in post-net zero climate risks. We need much more detailed projections, and we're working on this in the NEST Pub, but clearly future decision making is really dependent as well on maintaining Australia's Earth system modelling capability, so we can do the kinds of experiments we need to actually understand Australia's quite different climate future post net zero relative to other parts of the world. So just a few brief conclusions. Clearly, we're aiming for net zero emissions. Until recently, our climate projections haven't really aligned with our policy goals, and most of climate science hasn't really been focused on post net zero climates. It is a growing area, though, at the moment. We're starting to build an understanding of what a post-net zero climate might look like, but there's big knowledge gaps. And in the hub, we're trying to fill some of those gaps. Thanks.
Fantastic. Thanks, Andrew. Yeah, it's clear that there are real implications of this research, and particularly for Australia and New Zealand when compared to the Northern Hemisphere countries. Okay, so that's our presentations done. There was a lot there, I accept, but you have all been listening intently, and there are some fantastic questions. So yeah, we'll move into the webinar Q&A. I'm going to start with this one, and we've got our panel here. So Andrew, Sagat, and Andrea to answer the questions. Starting with this one. Do you expect that the next round of global climate models, CMIP7, will simulate more of these uncharted futures? Sagat, you're nodding.
Yeah, I can take this one. Thanks, Heidi. Yes, the answer is yes, that some of these will be better simulated in the next round of climate models. The timeline for that is not immediate. So you wouldn't want to be waiting around for this sort of information indefinitely, but yes, the answer is yes. There's going to be some sort of standard overshoot scenarios. They're still being designed at the moment. There's also some evidence that very high resolution global climate models do seem to capture, at least in some ensemble members, the Pacific warming pattern that we see in the past observations. So it is possible that some of these responses will appear in the next round of models, but again, that's yet to be played out. Anything I missed, Andrew or Andrea, please chime in.
I might just add the scenarios, the publication describing the new scenarios has just come out in Geoscientific Model Development. So if you Google scenario MIP CMIP7, you'd find that. The multiple overshoot scenarios, they should start coming out next year, the first data from the overshoot scenarios.
Yeah, I'm looking forward to see CMIP 7 and the model output as well, especially for the tropical Pacific, because as Sugata mentioned, there are some indications that high resolution models can capture a little bit better this Pacific warming pattern a little bit closer to observation. So hopefully this improves in the next generation of models.
Great, thanks, panel. Okay, so moving on to the next question. It'd be great to understand how this information could/should be used by organisations undertaking climate scenario analysis work for S2 reporting. So understanding that S2 reporting is the financial disclosures reporting.
I can chime in on that.
Yeah,
as well.
I think, Sagat, we've had some chats about this, so I feel like this should,
Yeah. So I think this is a really challenging problem to solve, but it is important. We've been doing a little bit of work thinking about climate risk assessment and how uncharted futures might fit into climate risk assessments. It's still in an early stage. The key stakeholder for this project is actually the Australian Climate Service. And so we're hoping that this will kind of channel through climate services who are accustomed to thinking about providing evidence base for climate risk assessment. But essentially, I think any climate risk assessment has to consider an evidence base that is appropriate for the type of decisions that they're making, right? So your decision for say something like long-term storage of nuclear waste would be very different from if you're planning a water tank in your backyard or something of that nature. So some kind of impact-aware selection of your evidence base is really important in risk assessment. We're not quite there yet. I don't think there are standard frameworks for this, at least in climate risk assessments. But we're trying to work on this and learn from other fields, especially in other areas like hydrology, where people have thought about these sorts of things quite extensively. But if anyone on this call has some strong thoughts on that and opinions and would like to inform us of things that they think we should think more carefully about, please do get in touch with us and we'll try and send that information on. I will just note as well, though, that, to some extent, we produce this evidence base and provide it as a service, but there are already a lot of users out there who are thinking quite deeply about these types of problems, and they come to climate services specifically asking about, hey, we've heard about this scenario or this plausible outcome, yet we don't see it in any of the projections that we can get from your data portals or your data sets. So can you tell us a little bit more? So I guess in the first instance, some of these things may be qualitative, some of them may be quantitative, but without probabilities attached. And we're going to sort of have to take a suck it and see approach to this for the short to medium term, but we're hoping that eventually this will become kind of a standard thing that has some sort of framework around it.
Yeah, thanks, Sagat. I think that was a really nice way to explain that. Okay, on to the next. One for you, Andrea. Great talk. The model warming you show is a multi-model projection. Have you looked at the individual models? How much of that signal is from them disagreeing with each other on exact location of warming and cooling trends, and hence cancelling each other out?
Yeah, that's a great question. So if we have, like, in the group, we had people who looked into that. So there is for example, a study by Shane McGregor who looked into how those models project this warming, both observations, like in the current climate, how the models simulate that and what they predict in the future. And it was really interesting, the result that he had. What he shows, so there is like quite a spread in the models, but most of the models I've predicted this warming to be more El Nino-like in the future, so a warming that is faster and stronger in the Eastern Pacific, so close to South America. And what he did was he looked into those simulations and separated those models that reproduced or simulated a warming trend that looks like similar to the observed trend in the current climate, and those who are the opposite, who simulate something opposite. And then he looked into what happens in the future. And what he saw is that those models that looks like more observations now, by the end of the 21st century, actually tends to produce more of an El Nino-like pattern, so a warming that is stronger in the eastern side of the Pacific, which was a really interesting result that we had from that project.
Fantastic. Thanks, Andrea. Does anyone else have anything they want to add or no? Okay, one for you, Andrew, to spread it around. These are very interesting and concerning results, but Access ESM 1.5 is only one ESM. Are similar results being found with similar like experiments using other ESM?
So that's definitely right. And it's actually only with the Access model that we've got these 1,000-year-long simulations. There are shorter simulations available from other Earth system model experiments. But those shorter simulations point to quite high diversity across models in climate response. Most point to near zero global warming under net zero emissions and cooling beginning under net negative emissions, but quite a spread, especially once you go beyond that to regional levels. Where we have the most confidence is that post net zero we'd expect Southern Ocean warming to continue and some Northern Hemisphere land cooling. Those areas there's a bit more agreement between models, but then for other areas there's a lot more uncertainty. And there's lots of other aspects of the climate system where there hasn't really been much work looking post net zero. So there's been a little bit of work on ice, and Antarctic sea ice we do expect to continue declining related to that Southern Ocean warming. Whereas things like rainfall changes, there's been relatively little work on post net zero changes, one or two studies, but again, high model diversity. So definitely need other modeling centers to run long net zero simulations and overshoot simulations like we have, because we do see changes unfolding over hundreds of years that we might be baking in through our emissions today. And we need to understand those because we're already passing on big problems to future generations as it is. And we need to, if that's even worse post net zero, then we need to really understand that and stop as well.
Great, thanks, Andrew. If there's nothing to add from Sagat and Andrea. Okay, so I think this is probably another one for you, Andrew. Why would post net zero effects on the climate be less favourable, at least in the short term, in the southern hemisphere than in the northern one?
Yeah, so it is related to the patterns of ocean circulation and the fact that the Southern Ocean, well, the ocean in general is slower to respond to reducing atmospheric carbon dioxide concentrations than the land is. So land areas see a quicker benefit post net zero, especially continental areas. So the interior of the Northern Hemisphere continents. The Northern Hemisphere has a lot more land than the Southern Hemisphere, so that's a key element. But also the Southern Ocean, there's a lot of upwelling. So the water that is upwelling hasn't seen some of it hasn't seen the atmosphere for a very long time. So it's still, even post net zero, seeing that kind of warming signal that was there before. So there's an element of that as well. The Southern Ocean is expected to just continue to warm for a very long time. There's a nice paper by Matt Chamberlain from CSIRO that calls it the freight train of the climate system. This very kind of slow, once it gets going, it's hard to stop aspect of the climate system. So that explains a lot of the Northern Hemisphere, Southern Hemisphere difference that we're projecting post net zero.
Fantastic. Thanks, Andrew. Okay, so yeah, these are really great questions. Thanks everyone for your participation. The next one might be one for Andrea. Do we have any idea as to why the climate models are misunderstanding the distribution of the Pacific warming? Will this have a compounding effect on the predictions of lesser oscillations, e.g. IOD, Indian Ocean Dipole?
Yes, that's another great question. And this is one of the things that we are trying to answer in NESP. So trying to understand what are the processes that are missing, if there are any processes that are missing in those climate models that, doesn't make the Pacific to simulate this warming pattern similar to observations in the current climate. So still research going on that space to try to answer why this is the case. And well, the fact that the Pacific it has influences on other ocean basins. So whatever happens in the Pacific influences what the Indian Ocean does and the Atlantic Ocean as well. So we do expect that depending on the projected changes in the Pacific mean state, this and variability, this will impact how the Indian Ocean Dipole, for example, will be projected in the future as well. So we have like some indications from preliminary studies and analysis, but one of the papers that we had in this group that was published by Christine's group, and she looked into the projections also in the other modes of variability, like the Indian Ocean Dipole and the Southern Annular Mode, and she says that the climate models currently project a weaker variability of the Indian Ocean Dipole in the future. Remembering that this future, it's an El Nino-like future based. Please follow up with me if I didn't answer your question fully, please feel free to email and we can have a chat later, but I hope, I could clarify some of the questions here.
Yeah, thanks, Andrea. There will be an email address that will pop up at the end if anyone, and I know a lot of you have asked for a list of the publications referred to as well, so we'll work on putting something like that together for everyone who's registered for today. And one of our great colleagues today has asked if there's a NESP fact sheet which describes the Pacific scenario issue. There is. It is well underway and in the final stages of approvals and publishing. So we will email the link out for that when, and the webinar recording will be available as well. We'll try to package it all up in the one page on the website for everyone, and we'll let you know where that is. Okay, so we've got a little bit of time left. There is a question here. Have you looked, this might be for Andrea, have you looked at recent volcanic eruptions, e.g. the 2022 Tongan volcanic eruption on the stratosphere and subsequent impacts on weather patterns and ENSO in your research on the South Pacific?
No, I haven't looked into that. I know that researchers at UNSW have looked into that. Researchers at the 21st Century Weather also have looked into that. Maybe, I don't know, maybe Sugata and Andrew wants to jump in and add anything if
I'm not an expert on this topic, but as you said, there have been a couple of papers by a few colleagues, including Chris Lucas and Martin Yuka on the Hunga Tonga volcanic eruption. The impacts of it are long-lived in the sense of seasons and years, but probably not in terms of multiple decades. But we can dig that up and send that through if that would be of use.
Okay, great. Yeah, thanks for the question. And one here, yeah, which I think is probably for you, Sagat. So what is your exposure to decision and policymakers? How are you engaging with state and federal government on these things?
Yeah, that's a fair question. So look, we're sort of tentatively dipping our toes into this engagement, but primarily through our colleagues at the Australian Climate Service, which is obviously federal government. However, we expect that the sort of information that we are researching and producing will be publicly available. And so we've had a couple of sort of just informal conversations with people from state government entities. So we've talked to some of the people at the NARCLIM group, for example, and people in the state, New South Wales state government dealing with water policy. However, at the present time, this work is, still in a research phase, so it's not directly being used to inform any policies. I think it's fair to say, Heidi, that we would hope that eventually these things would be of interest to state government policymakers and decision makers, but thinking a bit more carefully about how they should use this in conjunction with the other climate change projections that they have available. Some of the things are probably obvious, like, the overshoot and stabilization stuff that Andrew's talking about, I think will become sort of de facto standard at some point soon.
Yeah, and I guess Sagat and I have talked about this is kind of like an awareness raising exercise. People might not be able to apply this research directly in what they're doing right now, but they need to know that it's happening. Yeah, and that these are plausible futures. Yeah.
For example, federal agencies like APRA and Treasury have an interest in these types of scenarios. How exactly they plan to use it, I'm not sure yet, but that is an active discussion. They go directly to the Australian Climate Service to seek information on climate scenarios. So through our next user, the Australian Climate Service, we're hoping that some of this research will have a longer life.
Okay, look, there have been some really fantastic questions. I'm just going to really quickly read out. There's just two comments along the same lines of what we've just discussed. So just someone commented, it's critical that these research results are presented to high-level decision makers in Australian government and the private sector to encourage a greater commitment to net zero and preparedness. And then there was just one other that I'm going to read out. So not a question that needs to be answered, but for consideration, although the focus is on Australia, could some of these findings be usefully communicated to the governments of nearby nations like Timor-Leste and Indonesia? So yeah, some food for thought for the research team. Okay, so there's 2 minutes left, so I think we'll probably call it there on the Q&A. Thanks to our speakers for some really fantastic and super interesting and insightful presentations. I want to thank all of you, the audience out there, for your active participation and engagement. Thanks for supporting the Climate Systems Hub. We really hope you've taken something away from today, learnings, connections with others in the space, or a wish to just stay involved in the discussions around uncharted climate futures. So yeah, as we've discussed, there are a few resources on this work in the pipeline. We've actually got a blog written by Andrew. I think my colleague is going to pop that in the Q&A for everyone. So that's available now. And Andrea's more plain language fact sheet is on its way. And we'll share the links. And as we said, if you want a deeper dive into this research, we'll provide some links to papers of both Andrea and Andrew's work. Okay, so another great webinar next month. Please subscribe to our newsletter at the bottom of the Climate Systems Hub homepage, which I think that QR code will take you to. Keep an eye on your inbox for what's coming. And yeah, spread the word to anyone who's working in the climate science or adaptation space. Yeah, the link will be made available. And under the webinar recording, there'll also be a feedback form. So yeah, if you have ideas or you want to tell us what you thought, please do that there. Okay, I think that's it. Yeah, thanks again to all our presenters and for those who've been active behind the scenes, making today run smoothly. So yeah, thanks everyone, and we'll see you next time.